محسن من الحين مرحبين. تفضل يا محسن. Okay, so today we are going to talk about the admittance matrix. And as we define, if we have a vector of I, and here we have vector of V, and V the voltage, the node voltages, and I is the injected current in each node. Then the matrix here, we call it admittance matrix, V1. So we are looking for this one. So how to find Y very fast in very fast methods by using nodal analysis. I don't introduce a nodal. If you remember, nodal here على السيركت. If we say that this is 5 ampere, this is 2 ampere. So to find Y matrix, first we need to know nodes. So this is node number 1. So we assign here V1. This is node number 2, so this is B2. This is node number 3. And this is node number 4. Okay, but one of the nodes we are going to take it as a reference, so this is, let me say that it's our reference. And to write matrix directly, so express all R in terms of susceptance here, okay, or conductance. نعم؟
مو قاعد يصير شير.
ما اسمع.
مو قاعد يصير شير أقول.
مو قاعد يصير شير؟
بالنسبة لي مو قاعد يصير شير، ما أدري. الحين أوكي.
اوكي مثل ما قلنا ما ادري وين من وين كان ما في بث. Anyway, so to write nodal to write Y matrix for this one, we say that we're going to apply nodal analysis. So here we have 1, 2, 3, 4 nodes, but one of the nodes we're going to take it as a reference. Now we saw a reference. So then we have 3 nodes. Okay, so 3 unknowns. Second, we're going to express all R in terms of conductance. بدل ما يكون عندي R بيكون عندي أو Z. We try to, because we want to find Y matrix, then these we're going to express it in conductance. So let me say that this one we have it is 2 cells. This one 4 cells. This one 1 cells. This one 3 cells. Okay, how to write nodal analysis? We go here. So we say that the total admittance connected to this node, this 2, multiplied by V1 minus common with others. Okay, so this is common with 2. So, and this is common with the 3. E equal to the current is entering 5. خلونا نكتبها in shortcut. So we have a matrix. This is my Y matrix multiplied by V equal to I. V, and this is vector I. Right. So here we have V1, V2, V3, I1, I2, I3. So at node number 1, total admittance equal to 6 multiplied by V1 minus 4 multiplied by V2 minus 2 multiplied by V3 equal to current is entering, which is equal to 5. Node number 2, we have 4 plus 1 plus 3, okay, 8 multiplied by V2. Common with 1 minus 4, common with 3 minus 1 equal, we don't have any current source, so it's equal to 0. Node number 3, we have this 2, so 2 multiplied by V3. Common with 1 minus 2. Common with 2 minus 1. Okay, and the current is leaving, so minus 2. So just we need to solve the simultaneous equation to find V1, V2, V3.
دكتور مال نود 3 مو المفروض 3.
نعم؟
مال نود 3 مو المفروض 3.
كم كتبت 2 3 يس.
تمام.
Right. طيب. So similar here for the network we have something like this. يعني هذه السيركت عندي bus number 1, so this is V1. Okay, connected to bus number 2, or bus number 1, bus number 2 with 4 signals. And here we have another line with 1 signals connected to bus number 3. And bus number 1 are also connected to bus number 3 through line with admittance equal to 2. Okay, so this bus is connected to generator with 5 ampere. This bus also connected to generator with 2 ampere. And bus number 2 connected to the ground through admittance equal to 3 stands. So simply again here how to find Y matrix. So just go like this. Start from bus number 1. So total admittance connected to this bus. So 4 and 2, 6. Common with 2, minus 4. Common with 3, minus 2. Okay, similarly, bus number 2, total admittance here, 5, 3, 8. Common with 1, minus 4. Common with 3, minus 1. Okay, bus number 3, so here 3. Common with 1, minus 2. Common with 2, minus 1. هذه كل الآن هذه Y matrix. Okay, nothing else. ما في شيء. Okay, so يعني we add here just saying instead of we having a pure resistor here, we have the transmission line. It could be a shorter transmission line, so we have Z line. It could be medium transmission line, so we have to take shunt into consideration. We could have a tap changing transformer. Okay, that's here rough, but the way concept is exactly the same. هل في سؤال هنا؟ any question here? والله تخوفون وقت اللي ما تسوون. ما أعرف كلكم فاهمين كلكم رادين كلكم مو فاهمين. I don't know. طيب خلونا شوي so يعني we expand this one. Okay. طبعا اتفقنا transmission line. I don't have something like this. Okay, transmission line. It means that I have R very small, so then we have XL. So XL, as we said, that it could be equal to J5. But to write Y matrix, okay, mungkin نكتب J5 to write Y matrix, we need to change this one from X to B, so which is 1 divided by Jx. And instead of writing in terms of Z, we have to write it in terms of Y, so that it is equal to minus J.2. Okay, هذا اللي بسويه. فاحنا يعني نقعد نسوي كذي، بس هذا مو معناته اللاين كونكتد دايركت كان شورت، لا. خل في بالك بس حق يعني بدل ما نرسم الدكتور كل مرة. So this line, and I am going to put a value, which means that this is transmission line. طيب this is node 1, this is node 2, this is node 3, this is node 4, and let me say that it is equal to J. Again, for nodal, we said that one of the nodes we are going to take it as a reference. Okay, where is the reference one here? Where is my reference? When the reference with respect to where?
Node 4.
نعم.
Node 4.
لا, node 4 اللي هي one part of this. يعني node 4 كأنها هذه. It is node 4. And you know, it is always with respect to the ground and the ground. Okay. So this is with respect to the ground. Okay, also we said that before you start, okay, before you calculate Y matrix and Z matrix, so just check, is Y matrix exist or not? بدل ما نخلص الصفحة كلها وبعدين اكتشف إن لا, we don't have Z matrix or we don't have Y matrix. Okay, so what is Y? اكتبوا الY مالي. Just try it. حد عنده إجابة؟ ما في ولا واحد يتجاوب وياي هذا الشيء. كلش ما في ولا أحد. أوكي لا تجاوبون، خلونا نشوف شنو آخرته لنهاية السمستر. شو أقول لكم يعني؟
دكتور حليته.
أوكي شنو بيطلع الحين؟ هو نمبر 1 نمبر 1 نعم؟
ايه أنا حق نمبر 1 minus 2j.
اوكي
عقب j.
اوكي
0
اوكي
وj.
تمام اوكي. So y matrix here الخطوة الأولى, since this is j, it means that the line is equal to xl. ما فيها هني capacitor line. Okay, في الشنط ممكن, but in the line we have only r and xl. So r equal to 0, it means that we have xl. So first we have to change it to 1. So 1 over j is equal to minus j, minus j, minus j, minus j, minus j. Then y matrix, we have 4 passes, then we should get 4 by 4, square 4 by 4 matrix. So start from number 1. So total admittance connected with 1, so it is equal to minus j2. Common with 2, so it is minus j, so it's a plus j. Common with the 3, we don't have anything with the 3. Common with 4, minus j, so it is equal to j. Similarly, go for number 2. Total admittance equal to minus j3. Common with 1, so minus j, so it is j. Common with the 3, minus j, so it is j. Common with 4, again j. Okay, number 3, so we have minus j2. Common with 1, nothing. Common with 2, minus j, so it is j. Common with 4, again minus j, it is j. 4, it is equal to minus j3. Common with 1, j. Common with 2, j. Common with the 3, j. So sure, we can take it as, if you want, you can take minus j common, effectively. So it's minus j, so here we have 2, minus 1, 0, minus 1. And here minus 1, 0, minus 1, so this is a 3, minus 1, minus 1. And here 2, minus 1, 3. حبيت أخذ minus j common. If we say that the voltage, and then rule the voltage is given, so this voltage equal to 1 angle 30, and with respect to the reference, or let me say that this is my 0 reference angle, and this is equal to 0.9 angle 30 degrees. This is 0.95 angle 26 minus, and this one equal to 1.04 angle minus 68. Okay, what is the current? Okay, current injected, and we assume that we have a generator here, generator here, generator here, generator here. So if y, as we said, that y multiplied by v equal to I. So v, we have it, it is given. So 1 angle 0, 0.9 angle 30, 0.95 angle 86, 26 minus and 1.04 angle minus 68. So if you multiply y by v, then you will get injected current I1, I2, I3, I4. هل هذه واضح؟
Yes, دكتور.
اوكي تمام. اوكي خلونا نزيد الحين شوي شوي. اوكي طبعا we are not working with 4x4, with 2x2, 3x3. So we have a Y matrix form يعني for the whole country. It could be مثلا for Bahrain it's more than 100 bus. For US it could be, for example, more than 10,000 buses. If we want to modify this one, and then go minus J, minus J, minus J, minus J, 2, 3, 4. Let me say that we want to modify it. Modifications mean that we add line, we remove a line. We add tab changing transformer, we remove tab changing transformer. So adding and removing. And assume that Y matrix move diamond, it's same as this one. It could be, for example, 20 by 20. So 20 by 20, and we have a Y matrix, indeed Y matrix. So originally Y matrix, we have it with this line. So minus J, 2, minus 1, 0, minus 1, 3, minus 1, minus 1, minus 1, minus 1, 2, minus 1, minus 1, 3. So originally with the line here, we have it, and we have it. And this is actually, you are going to calculate it for the country, for whole country once. Might be the kilo الثاني, because we are not going to modify this one. We are not changing anything, so it is there. We have all the lines, all nodes, we have it. So we have this Y matrix. Once you calculate it at the beginning, then you have it. But now there is some modification. So let me say that the line which is connected between 1 and 4, we want to disconnect it for maintenance. How to disconnect the line? It means that we have a circuit breaker here and we have a circuit breaker here. We open the circuit breaker on both sides. Okay, so it means that we disconnect the line. So how to find Y modified now? So Y modified equal to the original Y plus the addition or subtraction. So if we add a line, so it is addition. If we remove, then it means we subtract it. Now, if we have only one line, a line between I and J, okay, between bus number 1 and bus number 2. and admittance equal to y. What is the admittance matrix for this one? You know how to find it. Okay, go to node 2 by 2. So 2 by 2 total admittance connected to this node, it is only 1. Yeah, 1. Common with others, so it is common with 2, so minus 1. Okay? Similarly, for 2, total admittance is equal to 1, which is 1. And common with others, so it's equal to minus 1. So then for a line 1, 2, connected between 2 buses 1 and 2, for example, then the admittance matrix is y equal to y matrix equal to the y is the line multiplied by the matrix 1 minus 1 minus 1 1. So let me apply it here. So now we say that we are removing, okay, this means that minus, removing line between 1 and 4. What is the admittance of the line between 1 and 4? It is equal to minus g. And احنا قلنا هني 1 minus 1 minus 1 and 1, so this is connected between 1 and 4. So at 1 we have 1, at 4 we have minus 1, so here 0 0. It's not affecting line number 2, 3, number 4, this is minus 1 0 0 1. So just add it together now. ما نبي نبدأ from scratch. I don't want to start it from here. خد في بالك. This is very large. Or يعني given it this one, so you should know how to modify it, whether you have the network or you have Y matrix. Okay, خلونا نقول how to modify it, especially if we have a large system. This is easy now to check it. But for a large system, we don't want to start it from scratch. يعني لو عندي هذه 20 ما في أبدأ من DD because I just remove one line. No, I want to start it from here, from the result that we have it. طيب, so minus minus it becomes a plus. So minus take minus J2 common. So here we have minus 2 plus 1, so it is equal to minus 1. Okay, this one is not going to affect. Wala hadi. Similarly here, 3 minus 1 minus 1, 0 minus 1, 2 minus 1, minus 1 minus 1. So the line that I removed from between 1 and 4 is going to affect 1 1. 1 4 4 1 and 4 4. That's the baqiyya will stay exactly the same. So 1 1 will be, this is minus 2 minus minus 1, which is plus 1, so it is equal to minus 1. And here we have a plus 1 minus 1, then it will be 0. Okay, here we have a plus 1, and here we have a minus 1, then it will be equal to 0. And here we have minus 3, plus 1, then it will be minus 2. And acceptable, because since we remove the line between 1 and 4, then the matrix element 1 4, that's equal to 0. It means that we don't have a line between 1 and 4. Okay, 0 means that there is no line between bus I and bus J. For example, similar here, this is 0, it means that there is no line between 1 and 3. هل هذه واضح؟
دكتور الماتريكس الصغيرة هذه واش ما تبين لأن
هاي الماتريكس اللي سويتها هني، ولكن هذه قلنا بين الاثنين يأثر في ال1 وال4. معناته إذا عندي باس 4 ب4 هذه 4 في 4 وهذه اللاين between 1 and 4 اوكي، فإذا بتصير واي بس قاعدة تأثر في 1 وال4، فهني بتصير 1 0 0 ناقص 1 وهذه ما تأثر فيها وهذه ما تأثر فيها. Similarly here we have minus 1 0 0 1. فهذه الماتريكس اللي كتبت هني الصغيرة هي دي. اوكي، لأن I remove so it is minus. هل هذه واضح؟
واضح دكتور.
طيب الحين let me say that for this one I have this matrix. And here now خلفي بالك أي line, if we remove any line or adding any line, it's going to affect 4 elements. 4 أماكن ممكن يأثر على I, J, Ji and Jj. The yet line and we connected here, it means that it's going to affect 1 1, 1 4, 4 1 and 4 4. Okay, خلونا بس نضيف شوية. If I say that I want to add a line between 1 and 3, okay, but this line is medium transmission line. Yeah. الحين في إضافة. هذه النتورك السابقة just between 1 and 3 ما اسمها البقية. So between 1 and 3, I add a line with J, and there is a capacitor. It is medium transmission line. Medium transmission line. So this is J, and this is J over 2. And then go to total shunt equal to Y. So this is medium transmission line, and we represent it by pi model. So then we use Y in the line, Z in the line, and Y divided by 2. Y divided by 2 here. Okay, how to find Y modified? Equal to آخر واحدة وصلت هني ها. So which is equal to minus J. That is 1 minus 1 0 0 minus 1 3 minus 1 minus 1 0 minus 1 2 minus 1 0 minus 1 minus 1 minus 2. No, plus 2, sorry. Okay, so you can do it in one step, or you can do it in steps. one step, it means that we add this one. Okay, best line هذا. بعدين السكند we add this, the third we add this one. ممكن تسويها كذي. أو ممكن تاخذ هذا اللاين and find y matrix of this and add it directly. يعني نسويها على 2. So addition of this one, it means that add minus y. Okay, this line is connected between 1 and 3. معناته هني 1, 0 minus 1, 0. It's not affecting 2. 3 هتصير minus 1, 0, 1, 0. It's not affecting number 4. Even by this way, we are taking care of line that is connected between 1 and 3. Okay, what's about shunt? This one is going to affect what? الكاباسيتور هذه. Affecting أي part. إذا جيت ركبت شيء هني في الباص هني وهني فمعناته when we want to find y for this one we said that يعني لو شيء موصله هني we said that this y plus this one total admittance connected to this which is it means that adding something to the bus it's going to affect bus number 1 but it's not affecting 2, 3, 4. So then it is going to affect bus II. So, which means that this capacitor is going to affect this bus. معناته اللي هي 1, 1. So then it is plus J over 2. It is only we have it here. هذه ما بتأثر في 2. ولا بتأثر في 3 ولا بتأثر في 4. Okay, while this one it's going to affect only bus number 3. It's not affecting anything else. Okay, so it is a plus J over 2. Only it's going to affect number 3. So these two we can put one here and one here. So you can find the total. So مجرد يعني addition. Okay, minus 1 plus half. So minus 3 over 2. قلنا الحين بس 1 و 3 اللي قاعدين يتأثرون. So 2 it will be exactly the same. This is same. هذه same. 3 minus 1 minus 1. 4 will be exactly the same. 3 2 1 minus 1. So 1 1 1 1 بتكون minus 1 minus 1 plus half. So minus 3 over 2. This is 0. This one it is plus 1 and nothing here. So plus 1. So this one will be minus 1. Then I have minus j common. So similar. 3 1. This is 0 plus 1. Okay, nothing here. So plus 1. So minus multiplied by minus plus. Okay, number 3, this is minus 2. Minus 1, minus 3. Minus 3 plus half. So minus 5 over 2. And I have minus, so that this is a plus 5 over 2. If you want, you can go here and check it. يعني ترسمها بس عشان يعني مرة واحدة تسوي لها check. Okay, so here we have minus J. Here we have capacitor J over 2. Here we have a capacitor J over 2. Okay, how to find it? To write Y matrix, go for bus number 1, total admittance connected to this bus. So we have minus J plus half, which is equal to minus 3 over 2. Common with 2, it is minus minus, so it is minus J. Okay, plus J, sorry. Common with the 3, again minus minus J, so it is equal to 1, meaning J. Okay, total admittance to 2, so we have this 3. Common with 1, minus 1. Common with 2, common with 3, minus 1. Common with 4, minus 1. So number 3, we have minus 1, minus 1, minus 1, minus 3, plus 1.5, which is 2.5. Common with 1, minus 1. Common with 2, minus 1. Common with 3, minus 1. Okay, 4, it is, we have 2. Nothing with a 1, 0. With a 2, we have minus 1. With a 3, also we have minus 1. هاي مجرد الcheck. But you don't need to do this. Always work with Y modify. How to find Y modify. طيب. So anything هذه طبعا كأنه we added to the bus, not to all line. كأنه we put half here and half here. So this one, it's only connected to the bus number 1. And this part, it's only connected to bus number 3.
دكتور
نعم.
دكتور يعني الماتريكس ما يأثر يعني في الكاباسيتر ما يأثر في الماتريكس؟
الكاباسيتر بلا أثر، بس أثر في وين؟ في الإليمنت مال 1 وأثر في الإليمنت 3 فلذلك إحنا هني صار عندي في ال 1 صارت 3 over 2، في ال 3 صارت 5 over 2. أما بقية الأماكن ما تأثر فيها. وين connected بتأثر فيها. اوكي يا عبد الرحمن.
اوكي
زين دكتور، شلون دريت انه هو بس ياثر على بس مثلا باص 1 او ما ياثر على باص 3؟ لان اكو صاير بينهم بين الترانسميشن لاين اللي بين ال1 وبين ال3، فبس ليش ياثر على بس؟
هذه اللاين عدل هاي كونكتد بين ال1 وال3. هذه اللاين connected between 1 and the 3. عدل بيأثر على 1 وبيأثر على 1 3 وبيأثر على 3 1 وبيأثر على 3 3. لو جبت شيء بس حطيته مني باص نمبر 1 هذه ما بيأثر على باص 2 و 3 و 4، بيأثر على only 1. هذه واضح؟
واضح.
إذا قلت إنه خلاص عندي هذه اللاين خدتها في الكونسيدريشن في البداية، أوكي، بعدين قلت أنا عندي كاباسيتور، هذه ميديوم ترانسميشن لاين، فإذا خدت هذين كلهم في الاعتبار. خدت 1 وخدت 1 3 وخدت 3 1 وخدت 3 3 في الاعتبار، هاي خدتهم ذلين. بعدين قلت ان هذه اللاين it's not short transmission line, it's medium transmission line, which means that we have a capacitor connected here. It is same if we connected here معناته connected with a bus. فاذا هذه بتاثر مع 1 1 وهذه بتأثر 3 3. هل هذا clear؟ أي شيء إذا connected directly to the bus is going to affect II bus، يعني element II. أي شيء connected between two buses اللي هي I that is going to affect II element في الماتريكس II IJ JI and JJ. أتمنى إنه يكون واضح هذا.
واضح دكتور، يعطيك العافية.
طيب خلنا نقول we have this one having network with a matrix الحين ال y that is equal to minus j 3/2 minus 1 minus 1 0 minus 1 3 minus 1 minus 1 minus 1 minus 1 5/2 0 minus 1 minus 1 2. Okay, خلونا نقول هذه this is my network. هذه my network بغض النظر how it's connected، مو مهم ال connection there is line there or there how it's connected ما عليه. المهم عندي here bus number 1 bus 2 bus number 3 and here we have bus number 4. So let me say that in bus number 1 we have a generator, and generator how we model it, it's like this. Okay, so and this is equal to whatever, but this one it's equal to J. Also, we have another generator in bus number 4. With admittance, it's equal to minus J half. Okay, and then we'll impedance equal to J half. Here we have a load. Okay, with J equal to 5, and here we have another load with J equal to 10. So how to modify my matrix? Y modify equal to diamond Y old. So this is my old one plus. So I'm adding here. Okay. لاحظ. Generator I can change it to current source, like bus number 1, in parallel with impedance. Okay, so current source equal to this is E, the current E1. So E1 divided by J. And this is J طبعا. J it means that it is X, so we want to change it to Y, so then it is equal to 1 over J, so this is equal to minus J. So in bus number 1, طبعا when we want to calculate Y or Z, it means that same as Thevenin equivalent. In Thevenin equivalent circuit, if you have a voltage source, express it as short circuit. If you have a current source, then just remove it and replace it with open circuit. So here you have voltage source, it means that's same as short circuit Okay, our current source is the same as open circuit. So then we have only shunt, and this one is connected to the ground here. Okay, but we need to change it to admittance, so then it is equal to minus J. Okay, so then minus J, this is connected to bus number 1, so it's going to affect only bus number 1. فهني بتكون minus J. Okay, bus number 2, we have a load with J equal to 10. J10, it means that 1 over J10 it is equal to minus J.1. It's going to affect only bus number 2. Bus number 3, again, we have a load, okay, with a J equal to 5, then 1 over J5, it's equal to minus J.2, and it is going to affect only bus number 3. And bus number 4, we have a generator, again, replace this one with a short circuit, and 1 over J half, it is equal to minus 2, it's going to affect bus number 4. The rest, طبعا كلهم zero. Okay, just add this one to the previous or the old ones, so you will get a new Y matrix. قبل ما تمشون خلوني اخذ الغياب. ما يحتاج ترفع، لا ترفع يدك يا محسن